The title of our work is, Interactive DPM for Thin Plants with the Latency Measurement. At first, we would talk about our motivation, purpose, and related work. Recently, projection targets are various objects, and many projection mapping works are created. For example, in this video artwork, natural objects are projection targets. However, these artworks required considerable time to register effect animations manually in the forest. And it is difficult to project onto dynamic targets. Therefore, our system registers projection areas on targets semi-automatically to reduce time for registration. And our system tracks dynamic targets. Additionally, we propose effect animations using the motifs of bioluminescence. These effects change interactively with touch sensor. With these methods, we propose an interactive dynamic projection mapping system for thin plants. Next, we'd like to talk about our method. This is the overview of our method. At first, we'd like to talk about our system configuration. Devices are set up such as in this figure. Next, we'd like to talk about specification and tracking of plants. In the first frame, projection areas are specified. Creators specify projection area among contours extracted from an input image. And each projection area is divided into triangular meshes to map the effect animations. After the first frame, each orange point is tracked in every frame. Next, this figure is an overview of our tracking method considering occlusion. Each point is tracked on an input IR image. The first processes are tracking with optical flow and detection of occluded points. The next process is tracking points on an edge image. The next process is recalculation. The final process is application of Kalman filter. Next, we'd like to talk about the interaction system. In our interaction system, touched duration and touched position are detected for generating interactive effect animations. Next, we'd like to talk about effect animations. Firstly, our concepts of effect animations are bioluminescence and light or shine from the natural world. And our system generates effect animations using the target shapes. By these motifs and our system, we make plants themselves appear to be luminous. We propose 4 effect animations of light, line, cell, and crystal. Each effect animation changes interactively using detected touch event. Then, we'd like to talk about each effect animations. Next, I'd like to talk about the results of our method with result movies. These results showed that our system can track various shape leaves with various movements. Additionally, deformed targets can be also tracked unless deformation is extremely. Regarding the tracking time, the system can track a single target with 10 points in 3.6 ms. Although the tracking time increases with increasing numbers of targets, we also measured the projected area outside the projection target as the latency with and without tracking for comparison. By this experiment, the latency caused by our tracking method is small enough compared to the system latency. Finally, we'd like to conclude. In this work, we propose the interactive dynamic projection mapping method for thin plants with robust tracking method against occlusion. Additionally, our system generates 4 effects to make plants themselves appear luminous as if they were bioluminescence. In future work, we expect that our system would be applicable to interior foliage that heals users. Besides, we would like to improve our system to increase its scale and the number. Thank you all for listening.